Of the millions of species that belong to planet Earth, what is it that sets us apart from all the others? Is it our inquiring minds? Our ability to explore, to discover, and to reason? Ever since the dawn of civilization, we have pursued the answer to one question: who are we? We have looked to the stars. We have searched our souls. But the answers seldom satisfy for long. Why are we so different? We connect, communicate, invent, and create. We are able to cure, to treat, to extend life, even to create life. We have built cities that touch the sky. We have flown amongst the clouds.
It's one small step for man,
and travelled far beyond.
one giant leap for mankind.
We challenge ourselves, and while we are not perfect,
We shall fight on the beaches. We shall fight on the landing grounds. We shall never surrender.
I have a dream
we endeavour to better ourselves.
that all men are created equal.
And now we have surely arrived at the golden age of technology. But our journey still continues.
Hello from the children of planet Earth.
Hola y saludos a todos. Shalom.
Who are we? We are amazing. We are human beings. And we have risen above all others to become the dominant species on planet Earth. Never before have we appeared to be stronger, more powerful, and more in control. Why is it then that at this moment in time, our species has never been sicker?
We think we're at the pinnacle of our existence. Look at all the technology that humankind has available now. And yet the reality is we've never been sicker, and it's going to get worse.
We have been facing a rising epidemic of plagues, from asthma to obesity to allergic diseases. This has been going on continuously over the last decades, and there's no real sign that it's letting up.
When you have asthma or inflammation within the lung, you see cells that are not normally supposed to be there invading that space, so you can't exchange the air quite as well. And this is an example of that invasion. And this is inflammation within the lung sacs.
The World Health Organization has declared non-communicable diseases have reached epidemic proportions. Diseases such as asthma, diabetes, celiac disease, obesity, cardiovascular diseases, some cancers, and mental disorders. These diseases currently account for over 60% of all deaths globally, and they are on the rise. The World Health Organization estimates total deaths from non-communicable diseases will increase by a further 17% within the next decade. The World Economic Forum and the Harvard School of Public Health have predicted that the cost of treating these diseases has the potential to bankrupt global healthcare systems by the year 2030.
So the model that was compiled together by the World Economic Forum and the Harvard School of Public Health estimated that the cost of non-communicable diseases between 2010 and 2030 would reach a staggering $47 trillion. That is a huge sum. To put this into context, the combined economic output of most countries in the world in a given year is less than $1 trillion, and they're estimating a cost of $47 trillion. It is a staggering sum indeed.
By the year 2030, almost half of the net worth of the world is going to go toward treating these diseases. That's not sustainable. We're bankrupting ourselves. And the problem is that we're creating an invalid society where we have people that are too sick to work. We don't have enough caretakers for those people. We're not going to have medical services to provide for that number of people. We simply can't afford it. We're hitting the wall right now.
We're increasingly seeing a world out there with what is really a public health time bomb waiting to go off. And the research that we're doing suggests that it's only going to get worse generation on generation. So tomorrow's generation really is, on the edge of the precipice.
Unless we face it, there's no indication that it's going to get any better. And I'm afraid that it will get worse. And that means shorter lives and lives with more misery and more susceptibility to the big pandemics. So there's a lot of risk out there. But we have the tools, and if we had the way, we can fix it.
4 lifestyle risk factors have been identified by the World Health Organization as driving this epidemic: smoking, misuse of alcohol, poor diet, and lack of exercise. But what if this isn't the complete picture? What if there's an important piece of the jigsaw that up until now has been missed? Scientists have recently embarked on a new journey of discovery. A journey that takes us through the lens of a microscope to discover who we really are and how a species could get so sick so fast. Let's rewind to the origins of life on Earth, to 3.4 billion years ago. All life on planet Earth evolved from bacteria. Over billions and millions of years, bacteria spread far and wide across the planet. In the deepest oceans, in the heart of mountains, in the atmosphere.
Life appeared on Earth about 3.4 billion years ago. And they were first. This is a microbial planet, mostly bacterial. And any other forms of life that came after had to deal with bacteria.
Some bacteria evolved into and with other life forms to become more complex organisms and complex ecosystems. For life at its healthiest exists as an ecosystem. A diversity of species that coexist, that live in harmony, that live in balance. But when the harmony is disturbed and the balance is upset, or when that diversity of species is reduced, the ecosystem may become vulnerable to disease and could even die.
If you remove half of the types of trees in a very diverse forest, it doesn't stay the same for the rest of the trees that are there. There's extra space, the dynamics of the interactions are completely changed. The insects, the animals may be changed because of habitat, and the entire forest takes on a totally different flavor, and in some cases a very unpredictable flavor.
This can happen in a local ecosystem. It can happen at a planetary level, but it can also happen at the micro level. It can even happen within us, because we are a walking ecosystem. The human body is host to trillions of microbes. They outnumber our human cells by an astonishing ratio of 10 to 1.
So it's estimated that we have about 10 trillion human cells in our body. And the current estimate is that we have about 100 trillion microbes living in our body. And that's how it is every day of our life.
We're 90% microbial and only 10% mammalian. The microbial part is said to be our microbiome.
So the microbiome are all the organisms that live in the human body. Bacteria, fungi, viruses, protozoa. They're the organisms that live in and on us that make us home.
We estimate that there are approximately 1,000 species in the intestine, approximately 700 in the mouth, approximately 300 to 400 in the vagina, approximately 700 in the skin.
You know, I used to be aware that I had organisms on my skin and in my gut and inside me. But to now think about this me, which is more microbe than human cells, I don't know, it's as if it connects me to the universe a bit more.
This relationship between bacteria and our human cells is one based on cooperation and collaboration. For thousands of years, this relationship has evolved. We provide a home, a habitat for the bacteria. In return, the bacteria in us and on us help provide security. Their importance in helping us function as humans should not be underestimated. Bacteria help regulate our metabolism, and they play an essential role in setting up our immune system.
We have grown up with our microbes over many, many generations. And in fact, we form what's called a symbiotic superorganism because we do things for each other. And those things are very important for the health of the total organism.
Our own ecosystem has thrived, a diversity of species in balance. But in the last century or so, this ecosystem has become under threat.
Just like the forest, you can't start cutting out major sectors, major tree species, reduce the diversity and expect things to stay the same and that forest to stay healthy. It doesn't, and we don't when we've lost the diversity in our microbes.
The way we live our lives has changed dramatically, and scientists are now hypothesizing that this is having an effect on our ecosystem. The balance has become disturbed, the scales are starting to tip, the ecosystem has become sick.
Let's say you have 10 diseases that are rising at the same time. Each one might have a separate cause. Or perhaps there's one thing that's fueling them all, that's causing all of them to rise. And I think that one thing is a change in our microbiome, and what I've called missing microbes, or the disappearing microbiota hypothesis, that our ancient microbiome, which protected us against many diseases, is degrading. And with that degradation, these diseases are being fueled.
When we compare our microbiomes with those from peoples living isolated in jungles of South America, for example, with no record of exposure to antibiotics before, we estimate we have lost about a third of the diversity of our microbes.
It's pretty clear that our diversity is going down, and that to an ecologist is dangerous because the diversity protects us. We have evidence that the organisms are disappearing, so the question is why? And I would say part of it is modern life. Nothing prepared our microbiome for clean water and smaller families and cesarean sections and antibacterial substances everywhere, and of course 70 years of antibiotics.
In 1928, Sir Alexander Fleming made a world-changing discovery: penicillin.
Initially, very small amounts of penicillin could be made. In the case of penicillin, it's caused by a fungus or a mold. And in the early 1940s, while World War II was going on, scientists were looking for a good source of penicillin, a mold that really produced a lot. And that mold, where most of the penicillin, even till today, came from one moldy cantaloupe in Illinois. And that was the great strain that produced huge amounts, and we could harness that to do good for us.
That moldy melon and the arrival of mass-produced antibiotics changed the face of modern medicine.
For those of us who've lived in recent decades, historically we've lived in quite a privileged period of human history because we've had these powerful medicines to fight these bacteria that cause disease.
Antibiotics underpin most of medicine. It's hard to do surgery without antibiotics. It's hard to do transplantation or chemotherapy. We need antibiotics to help protect us against bacteria. And in consequence, antibiotics are being used more and more and more. And certainly here in the United States, they're very much overused.
Widespread use of broad-spectrum antibiotics kill off good bacteria as well as disease-causing pathogens. Combine this with the use of antibacterial products that claim to kill 99.9% of all bacteria, and it seems that over the past 70 years, we have been waging war on our microbes. This may be taking its toll on our microbial populations. But where does our microbiome come from? When are the seeds of our bacterial ecosystem sown? The critical time for seeding our microbiome happens during childbirth. Preparations for founding the baby's bacterial ecosystem actually start inside the mother during pregnancy. Scientists believe the baby grows up in a near-sterile environment in the womb. Emerging research suggests that a small number of bacterial communities may be present in the placenta, and other recent research suggests that small colonies of bacteria might also be present in the womb, but the main seeding event occurs at birth. In the weeks and days leading up to the birth, key bacterial species gather in the mother's breasts and in her vagina. Then during labour and birth, a special cocktail of bacteria is transferred from the mother to the baby in the birth canal.
And as the baby starts going out through the birth canal, the baby is acquiring the mother's bacteria from the vagina. The baby is covered with the bacteria. The baby is coated, is swallowing the bacteria. And that's the baby's first introduction to the world of bacteria, the world that we all live in. That's the founding microbiome for that baby.
Rodney Dietert, professor of immunotoxicology from Cornell University, believes that this microscopic process that happens during childbirth is critical for future health. His hypothesis is called the completed self.
The completed self is the idea that we are intended to be majority microbial from the very beginning of life. At birth, we are supposed to be 90% microbial, and that's the way it should be. That's the way it is when we're healthy. When the baby comes down the birth canal during vaginal delivery, that is the major seeding event. And we know that the gut microbes in particular are absolutely crucial in what happens for the immune system and in the capacity to break down different nutrients and different environmental chemicals. That's where the action happens. So that is probably the single most important event that's going to chart the course for whether that baby becomes complete and whether that baby experiences a life filled with health or one filled with disease.
The next stage for the microscopic transfer of microbes happens during skin-to-skin with the mother. Immediate skin-to-skin contact allows for the transfer of skin bacteria from mother to baby and is important for other hormonal and biological processes.
When that baby comes out, the natural habitat for that baby is the mother's body, and that baby should go directly skin-to-skin with the mother. When that happens, oxytocin is released and the cortisol starts to dampen down that was released during labour. The baby starts to smell and search for the mother's breast. The skin to skin is so amazing that the mum will warm up if the baby's cold, that being on the mum's skin will regulate the baby's blood sugar, it regulates the baby's breathing, it reduces crying, it reduces stress. It basically brings that baby into the world in the gentlest way possible and helps it to adapt to being outside in the world.
And it's an absolutely critical time. You know, the oxytocin levels are high. It's a moment when the mother and the father will see the eyes of the baby, and often this kind of position, the baby recognises the human face. They will never have that moment again. It's the first stage of falling in love, and it actually sets a template for future life.
For the baby to have immediate skin-to-skin contact with the mother is the perfect situation to establish breastfeeding, the next critical step in terms of the physiological process of birth.
When that baby then breastfeeds, there's a whole nother connection and cascade of hormones that occurs. The mother's releasing prolactin, she's releasing oxytocin, she's calming down, she's relaxing, she's falling in love with her baby's feeling the same for her.
Breast milk is a very complex substance, exquisitely designed to provide everything needed by the baby. But importantly, breast milk also provides everything needed by the baby's microbes that have just been seeded in the baby's gut.
In breast milk, you have several things that the baby needs. First of all, the mother provides certain immune hormone-like substances that are really important. Some of those are anti-inflammatory, and that's going to be part of the challenge. The baby needs those. She provides antibodies as well. And in addition, she provides some microbes from her own breast tissue, but she also provides sugars, oligosaccharides they're called.
For many years, scientists were really puzzled by one of the main components of breast milk, the sugars, the oligosaccharides. These were indigestible by the baby. So why were they there?
It's very, very complex, but it especially contains indigestible carbohydrates, indigestible substrates that the baby will not be able to digest, but the good bacteria will.
It's only recently that scientists have discovered that the sugars were there to feed the newly seeded bacteria in the baby's gut, to feed, to nurture, and to help them grow in number.
Breast milk is the best source for the baby's microbes, and breastfeeding beyond 6 months where possible, even up to 2 years, a lengthy duration of breastfeeding is really important because breast milk contains the sugars that help the baby's microbes to mature themselves. They are exquisitely designed for those microbes, and they're the best nutrient source. And so that becomes extremely important to nurture a well-seeded microbiome that's in the baby.
What happens if you interrupt this complex process of feeding the newly seeded microbiome?
If we break the natural rule of breastfeeding naturally, we may also be helping to compromise the education of the immune system of the baby.
When a baby is born, its immune system is completely naive. It doesn't know what is safe and what is dangerous. So the baby's developing immune system has to learn which bacteria are the good ones that should be tolerated and which bacteria are harmful that should be attacked.
It is a fascinating story already from what we're learning about the interaction between the gut microbiota in the infant as it develops and also the development of the infant immune system. They're connected. So as the gut microbiota is developing over that first year of life, so is the immune system. And the way it is developing is it's learning what is friend and what is foe. What is a beneficial good bacteria and what is harmful.
So what we have here is an image of one of the types of immune cells in our body called a macrophage. We study the mechanisms of exactly how other cells in the body are told, hey, we have an infection, come help us out.
The first bacteria to arrive in the baby's gut kick-starts this process. They prime the baby's immune system. Scientists believe that the immune system has one chance to do this, one chance for optimal future health.
This is extremely important, and if you upset this process, which is so crucial in the early life, then we may have consequences later.
We need our microbes in place at birth or shortly thereafter. And the reason is that that's when the immune training needs to happen. You may have an opportunity to correct the balance in the microbes by taking probiotics later in life, and that's great in a way, but it doesn't answer the problem with the immune system. There's one chance, there's a narrow window. If we miss the window at that point, then the immune system never matures correctly, and that can lead to haphazard responses and production of disease later in life.
If this complex seeding and feeding process is interfered with, this could affect the development of a child's bacterial ecosystem. This could affect metabolic processes and the immune system. As a result, this could make our children more susceptible to disease. Scientists are hypothesizing this is what could be happening with babies born by caesarean section. Caesarean rates have skyrocketed in the past few decades. In the UK, a quarter of all babies are now born by caesarean section. In the US, it is around a third. In China, it is about half. And in some private hospitals in Brazil, the caesarean rate is over 90%.
The rate of caesarean section is going up around the world. Now, in many instances, that is a jolly good thing because caesarean section can be life-saving. And there are parts of the world where women need caesarean sections for their own health, for the health of their babies, and they don't have rapid access to them. So we've got a paradoxical situation where in some parts of the world, women who need caesarean sections can't get them. And in other parts of the world, women who don't need caesarean sections are having their deliveries in that way.
My personal view of why the caesarean section rate has been rising steadily ever since I qualified is that we keep making caesareans safer. And because they're safer, that means the threshold of risk in labour at which we would resort to a caesarean gets lower and lower and lower. And it's not just the professionals who perceive this, the women themselves perceive caesareans as being relatively safe, which of course they are, and hence they're more likely to request caesarean section at a lower level of risk than they would have done 20 or 30 years ago.
Caesarean sections are sometimes essential and can be life-saving, but there are some known short-term health risks for the baby associated with being born in this way.
Babies born by elective caesarean section who haven't been exposed to the normal process of labour do have more in the way of short-term health problems. Perhaps the one that's most well known is respiratory problems, and they can be quite unwell with these respiratory problems. They can need intensive care. Obviously the majority just have mild degrees of respiratory problems. These babies also find it much more difficult to establish feeding. They're much more likely to have low blood sugar levels. They tend to be sleepier, a bit more drowsy. The short-term problems are well recognised, but where our research is asking new questions is, are there long-term implications from having been born by caesarean section as well?
Until recently, the main emphasis with caesarean has been to avoid the damage of difficult labour to the mother and then to the baby, because the baby can get short of oxygen during a difficult labour. And it's been assumed that if you deliver the baby in good condition by caesarean, that therefore the baby will do perfectly well in the long term. Unfortunately, it turns out that there are some aspects of normal natural birth through the vagina which are missing when you do a caesarean section, and it's turning out that that may lead to some problems for the baby in the long term.
If a baby does not pass through the birth canal, that baby will bypass the mother's bacteria, encountering instead bacteria potentially from other sources. Scientists are hypothesizing this could come with its own set of problems.
So there's several issues with caesarean delivery. First of all, it bypasses the process where the baby's gut would be seeded by the microbes from the mother's gut and established at birth through vaginal delivery. In addition, the mother is likely to have been administered drugs or antibiotics that will affect both her microbes and the baby's microbes. And finally, with caesarean section occurring in hospitals, the baby is going to get gut microbes from somewhere, and unfortunately they may be of the kind that exist in hospitals and are not necessarily healthy for the baby, such as Clostridium, for example.
And we think, and it's still a hypothesis, that that's part of the problem that this generation of kids have, is their immune system has been primed by the wrong set of bacteria.
The seeding of the baby's microbiome could be critical not just for the gut and the developing immune system, but the latest research is also linking the seeding of the baby's microbiome with the development of other tissues, including the brain.
The baby's microbes that are seeded by the mother into the gut are important not just for the gut, but for most of our tissues. And one example is the brain, because we now know that depending upon the seeding that occurs and the diversity of the microbes in the gut, that affects the brain and the nervous tissue. So that a number of neurobehavioral disorders have been linked with the microbes being not diverse enough, that the seeding is inadequate. And as a result, the byproducts that are produced from normal nutrients by that baby affect the brain in ways that produce behavioral alterations that can be a problem.
The fact that we can get these long-term problems for the baby doesn't mean that we should stop doing cesareans. They're clearly going to go on being necessary. So the challenge for us is to find ways of dealing with this particular problem. Just like we've improved the surgical technique, we've improved the anesthesia, we now need to improve how we deal with the baby so that it overcomes this particular problem.
If a mother must have a C-section, then there are things that she can still do that can be really helpful for the baby. So it's very important to have immediate skin-skin contact when that's possible. Breastfeeding of a significant duration, 6 months or more, is really important, again, to nurture the microbes in the baby's gut. In addition, there is an idea of using vaginal swabs and how that may be important in attempting to seed what the baby would have gotten had the baby had vaginal delivery.
Dr. Maria Gloria Dominguez-Bello is leading a pioneering study across multiple countries where babies born by caesarean section are inoculated with bacteria from their mother's birth canal.
So what we do is we take a gauze 8 centimeters by 8 centimeters. We wet it with a sterile saline solution. We fold it and we make like a tampon with a lot of surface exposed. We fold it as a fan and we incubate it in mom's vagina during the last hour before the procedure, before the C-section. And the surgeon takes the gauze out just before the procedure, which lasts it's really fast. It lasts between 15 and 20 minutes. So the gauze is put into a sterile container while the surgeon does the procedure. And when the baby is born, the first thing the baby will see immediately is that gauze. We pass it through the mouth first, then the face, and then the rest of the body. So we are currently doing this study. It's a big study. The full results will not be ready before 2 or 3 years. But we have decided to take the first babies and publish a month of their progression, of their bacterial communities. And what we can tell so far is that the babies inoculated, although they were born by C-section, they look more similar to vaginally delivered babies than to C-section delivered babies.
Swabbing newborn babies could help introduce the mother's bacteria to babies born by caesarean. But there doesn't appear to be a substitute for the complex interplay of hormones and stresses of natural childbirth that could be critical for future health.
The single most important thing we can do for a healthy baby across a life course is to ensure that microbial seeding occurs completely at birth through vaginal delivery when possible, the skin-skin contact occurs, and that the microbes are supported through breastfeeding of significant duration. This should be on every birth plan. Every health professional, every medical professional tending to the pregnant woman, to the birth process through infancy should be aware of these things, should be aware of the importance of the microbiome and supporting a healthy microbiome, because that's what's going to influence the health across a lifespan versus one filled with disease for that child.
Science has shown that bacterial populations in the gut are passed on from generation to generation during vaginal birth. So a grandmother has similar bacterial species in her gut as her daughter and even her granddaughter if they all have vaginal births. And so bacterial transfer can be viewed as a kind of maternal heritage that is passed on from generation to generation, from grandmother to mother to daughter. But what happens if one generation gives birth by caesarean section? This could be breaking the chain of maternal heritage. Could we be producing a generation of children who are missing vital bacteria? And could that be passed down and down for all future generations? What is not known is what the consequences of this might be for humanity. There's other transgenerational processes possibly happening during childbirth that could also have ramifications for our species. This is the emerging field of epigenetics in childbirth.
Epigenetics, very, very simply, are heritable changes in gene expression that are independent of the underlying DNA. So while your DNA is what you inherit from your mum and your dad, there are parts of your gene that switch on and switch off. So epigenetics is above the gene. And epigenetics is simply saying that there are changes made that silence parts of your genes that can then be passed on into the next generation.
And what we know happens at birth is that there are a whole series of genes that you need to be switched on in order to survive post-birth. And there are genes that you've had switched on before birth that you actually need to switch off. You no longer will need them throughout life. And birth appears to be the point at which you switch genes on or switch them off.
A very, very long period of evolution has brought us to the point that we are at today. It's highly plausible that normal labour and normal delivery is in some way a programming event, and by that I mean that it turns on genes that affect certain health trajectories.
Anything from things occurring in the actual environment of the mother giving birth to interventions that can occur during the birth process, like giving antibiotics, inducing labor, providing the mother with Pitocin, C-section delivery, forceps delivery, and things of that nature. All of these interventions, we believe, may have an implication or may cause changes in the epigenome that can have later impacts on health outcomes.
The actual process of labour as well as vaginal birth could be critical for long-term health. It could be that the stress of labour is actually good for the baby. It could help prime the immune system epigenetically via a complex process involving hormones and also have a long-term effect on metabolism.
What evidence do you have? So at the moment, we don't have a lot of evidence that there are epigenetic changes during pregnancy and birth. We've got good epidemiological evidence showing that there are links between ways babies are born and disorders late in life. But there are a couple of studies that have come out showing that there are methylations or changes seen genetically with cesarean section. There are also studies showing that antibiotic use, even antibiotic use during labour, has been able to show some evidence of methylation. So we've got some evidence, but because we've skipped this whole area, nobody's been looking. And so we're now saying turn the microscope on birth. It's a really important part of a human being's life and therefore probably has much greater impact genetically than we ever thought.
If there have been few large-scale university research studies about the long-term effects of caesarean sections, the same can be said about another commonly used intervention, the use of synthetic oxytocin to induce or speed up labour.
I have spent the last 33 years trying to answer the question you have asked me, what are the long-term consequences of Pitocin or syntocinon? And I would say we still don't know. The only way we could find out would be to do an experiment. And I don't think anyone really wants to be in that experiment, but because the procedures that are used to facilitate birth, the use of Pitocin, syntocinon, oxytocin's all the same thing, has increased so much, we're now at the point where we have almost nobody left to study that hasn't been exposed to it in some way or another.
Animal studies are indicating that exposure to synthetic oxytocin around the time of birth can have detrimental outcomes. But we can't study the same kind of mechanisms in humans. So all we have are correlational studies, but we certainly need large population-based studies where we can look at associations between birth exposures and long-term outcomes.
With the potential transgenerational effects of epigenetics, long-term effects that can be seen for up to and even beyond 100 years into the future, we could be altering genetic components of future generations right now without even realizing.
We're interfering and altering so many biological processes during labor and childbirth. We don't have a clue as to what kind of long-term, heritable, intergenerational changes can take place. It's irresponsible to be biologically manipulating this emerging system in the baby, this sensitive transitional system in the mother, and not know the consequences.
You know, people who work in epigenetics will tell you, you are what your grandmother ate. This can go on to several generations. So we need to start the research now so that we haven't waited several generations before we've got really good answers to things that we can correct today.
Whatever the actual cause, whether it is epigenetics or alterations to the baby's microbiome, a mixture of the two or possibly another reason altogether, it appears something is happening with caesarean section that is being linked to increased risk of disease later in life.
Epidemiologically, the data is quite strong as a link between caesarean section and long-term outcomes. Large population studies have shown that asthma is increased, about a 20% increased risk of asthma if you're born by caesarean section in childhood compared to if you're born by vaginal delivery, about a 20% increase in the risk of type 1 diabetes. Smaller increases in gastrointestinal problems, so gut-related conditions, Crohn's disease, celiac disease. All of those conditions, of course, are linked to the immune system, which is a common theme with them. Obesity, we're seeing, a similar kind of increase in the risk of obesity.
Scientists at Imperial College London have recently conducted a study into the link between caesarean section and increased risk of obesity later in life.
We've just completed and published a very large systematic review and meta-analysis. In other words, we put together all of the published world literature which examined the relationship between obesity and overweight and mode of delivery.
So we took data from over 100,000 people, from adults born from around the world, born by either caesarean section or vaginal delivery, and we showed that if you were born by caesarean section, on average you had half a unit BMI greater than if you were born by vaginal delivery. Half a unit increased BMI as in an individual means very little. I could gain that and lose that in a week and wouldn't notice any different health impact. But across the population, half a unit BMI increase is a massive public health risk. You see a very large increase in strokes, in cardiovascular disease, early mortality, etc., all through half a unit BMI increase.
As scientists are very keen to point out, an association is not the same thing as cause.
We don't know whether or not being born by caesarean section causes certain health problems, causes you to be overweight or obese. We know there's an association, and I have to emphasise a phrase in science that is really, really important, which is that association does not mean the same thing as causation. So, for example, you might find that the increased risk in being overweight or obese if you're born by caesarean section is actually because your mum was overweight, and the risk isn't anything to do with how you were born, but it's to do with the genes that you inherited, or it might be due to the environment in which you were brought up. So you can see that we have to be really careful about whether or not actual mode of delivery causes these problems. But it's clearly a very, very important problem, because if it is causal, if caesarean section does cause health problems rather than just being associated with them, then we potentially have a very big problem on our hands.
Over the last 20 to 30 years, we've seen dramatic increases in childhood asthma, type 1 diabetes, celiac, childhood obesity, and we've also had increases in caesarean delivery. Does caesarean cause these conditions? No. What caesarean does is to not allow the baby to be seeded with the microbes. The immune system doesn't mature and the metabolism changes. It's the immune dysfunction and the changes in metabolism that we now know contribute to those diseases and conditions.
The story of later life disease associated with caesarean section doesn't stop there.
With caesarean delivery, the problem is those children are at an elevated risk of asthma, type 1 diabetes, celiac disease, and obesity. But that's just the tip of the iceberg. One of the things that happens with caesarean delivery, increasing the risk of these childhood diseases such as asthma, celiac disease, and type 1 diabetes, is that the other diseases where there is elevated risk may occur later in life, that the children are essentially programmed as a result of these early environmental conditions for the appearance of subsequent chronic diseases. We know that non-communicable diseases are interlinked, that if you have one, particularly as a child, your chances of having another and maybe a third later in life are very much increased. So for example, a child diagnosed with asthma, it's not just asthma that we need to worry about, because that child has a greater risk of being obese, of having behavioral issues, and eventually developing lung cancer than children who don't have asthma. The same thing happens for children with type 1 diabetes and very specific non-communicable diseases. In that case, many of them are autoimmune diseases. The same thing for children with celiac disease, which is increasing in prevalence. So that it's not just the first disease that's encountered in childhood because of low microbial diversity, but it's the progression of potentially multiple chronic diseases or non-communicable diseases, each one requiring heavy medical intervention and drug therapies.
This emerging science all seems to be pointing in one clear direction, that there is a link between caesarean section and increased risk of our children developing not just one, but multiple non-communicable diseases. If we continue on the same path, it is conceivable that our actions could actually be accelerating us towards the disaster scenario predicted by the World Economic Forum and Harvard School of Public Health, the bankruptcy of our global healthcare systems.
You could also actually begin to think about non-communicable diseases as a deeper threat to national security. If we don't find ways for managing these diseases better, if we can't come up with cheap or cost-effective ways to address them, we're going to be landed with quite a big socio-economic problem that could be destabilizing in the worst case scenario. And so I think that's why also we need to raise more awareness around non-communicable diseases and get more coordinated action on this.
Non-communicable disease is now being recognized by world leaders as a serious global health threat. Action plans are being devised. But what appears to be completely missing from their agenda is the link between how we give birth and increased risk of our children developing multiple immune-related diseases later in life.
Well, one thing is for sure, is that if you take information to very, very busy world leaders, that is not the subject that is actually being debated, you stand very little or no chance of being heard. So it's crucial to take a subject that they're all working on first, and then say, in order for you to achieve the goals that we have all agreed to, you need to know this.
Are we too late?
I don't think we're too late, but we're definitely not too early either. This is a really big challenge, something we have to confront urgently. We have to change our thinking. We're going to have to get our brightest minds on this. We're going to have to get coordinated action both within countries but also between countries. And I think this is one where we're all going to have to pitch in together for the benefit of humanity.
Looking into the future, if antibiotics are no longer effective because of antibiotic resistance, and if we are unwittingly producing a generation of children with compromised immune systems, we could be sending our children out into a world of disease with their shields down. You can imagine the situation that if we continue reducing our bacterial diversity, our children could become more susceptible to infectious disease, including pandemics.
Well, the worst case scenario is in fact really terrible. And that is that we know that the good microbes of our body help protect us against the bad microbes. And so the risk is that if our microbes get too depleted, then we will become quite susceptible to an invader, a pathogen that arises somewhere and that could spread through our communities all over the world and cause a terrible plague or pandemic. Pandemics have occurred in the past, and we're vulnerable to pandemics. There are many more of us, we live closer together. Because of jet planes and other forms of travel, we're no more than 2 days away from any village in the world. So we have a very large interconnected community, and that makes us more susceptible to pathogens. And now if our coastal defenses are weakening, If we don't have the diversity, then we're more susceptible. And that's a scenario that I've called antibiotic winter, which is very bleak because it could really cause untold numbers of death. Now, if this happened tomorrow, it's too late. There's not that much we can do about it. But if it were going to happen 50 years from now, then we could find ways to protect against it and to restore our diversity. And that's what we have to do.
Could we now be doing to ourselves what we have already started doing to the planet? Humankind's impact on our inner ecosystem seems to be mirroring the influence we are exerting on our global macro-ecosystem. We're disturbing the balance.
Our westernized lifestyle and our technology, which has given us so many good things, have also collateral damage. And we have to understand what is the impact and try to correct it before it's too late, both at the level of the planet, of our environment, of our macro ecosystems, and of our own microbial ecosystems that live with us.
Over a quarter of a century ago, scientists warned mankind was causing damage to our own planet. The scientists faced fierce resistance, and the repercussions of inaction, perhaps, are now being witnessed. The same warnings are now being echoed with respect to our own species. Let's not make the same mistake again. We can't afford to wait decades before action is taken, before wide-scale studies are commissioned, before the global community wakes up to what we may be doing to ourselves. And it all starts with birth.
What's the worst case scenario if we don't change?
Well, the worst case scenario if we don't change is that the humanity is heading for a huge health crisis, which will impact on us economically, it'll impact on our quality of lives, but also most significantly it's going to impact on the next generation. And it takes several generations to sometimes sort out the problems we've created previously. So we absolutely have to act now. If we're wrong, and if it was all smoke and mirrors, then we've done no harm. However, if we ignore it, we've potentially done huge harm. So that's why we actually have to act now.
I think we're in the midst of the largest experiment in human history, and we are not running the controlled studies that we need to know what the consequences are. I think that's unethical. I don't think it's acceptable. I'm not saying we shouldn't use the procedures and the medical advances that we have. I'm saying we owe it to the children that we're producing to know everything we can about what the consequences for that child of those procedures are.
I think it's extremely urgent because the sooner we can identify and if there are truly risks for negative health outcomes down the line, we can make a significant impact on health for all mankind.
For the first time ever, the obesity epidemic has reached such proportions that we're likely to see children who have a shorter lifespan than their parents or their grandparents. If how we're born affects our chances of long-term health, can do anything to reduce this obesity epidemic, even by a very small degree, we need to do something about this now. We need to seize this opportunity to actually turn the course of human health.
The jigsaw is sort of being built, isn't it? And this feels like another really important bit of the jigsaw. It's pointing us in a very clear direction, which is, you know, childbirth is important for the future health of our children, and we need to get it right.
We have to alert the public about what's going on so that they understand what the stakes are and where this is coming from. And we need to do more science to pinpoint the problems and also develop the solutions.
If we're right, and I think we've only just begun to scratch the surface on how right we may be, then we have got potentially a huge issue coming up to face us. And a bit like climate change, Even though we don't have all of the answers as to what's going on, why and how severe that issue might be, we're putting resources, we're putting politics, we're putting policies behind it, and we're changing things, because it would be so dreadful if we allowed this to escape and become a bigger problem than it may.
It's a global problem. It's not an American problem, it's not a European problem, it's not a Japanese problem, it's not a Chinese problem. It's a humanity problem. It is.
If we don't take the bigger perspective and fund research that asks the smart questions, the big questions, the developmental questions, intergenerational questions, epigenetic questions, how do we know that we're not altering the course of humanity?